Excellent. Hi all. As I just said, we'll be doing a little introduction into R and how we're going to look at some temperature and humidity data and how you can pull it all into a report. And let me start sharing my screen so that you can see what I'm doing. I think I'll be more used to this by now, but not really. Okay, so here's just an outline of what we're going to do today. So here's where we are. We'll just look at R a little bit. We're going to start off with an R Markdown report. We're going to get some data. I have some data stored in my GitHub site, and I'm just going to show you how to work with that, and also how you can download data locally to your computer. We're going to do some graphs with the data, and then Q&A. But feel free to jump in and ask questions if you need to. If there's anything that needs a bit of clarification, I'm by no means a coder. Absolutely self-taught, and a lot of the technical terms we can work on it together. Also, it's quite good asking questions, as in I'll be using like tools like the internet to like if I'm really stuck on something, and it's a good way of like how you can solve problems. Like if you get stuck on a particular question or a bug or something comes up that you weren't really expecting, internet is your friend, sort of thing. So just going to jump straight in and show you where you actually get R from. So if it's the first time you've used R, I sent some details in the mail out and on the Slack channel. But this is a website for R. It's a statistical computing and graphics package. It's a software environment, and if it's the first time you've seen it, it's not the most, considering it does like state-of-the-art graphics, it's not exactly particularly too welcoming. But if the first time you've seen it, where you really want to go is really just download it to begin with. And when you hit download, you pick one of the repositories. So there were several repositories. There's hundreds of repositories around the world. You just when it was first being distributed, it was just hosted in different organizations. So we're just going to use the cloud. We'll just use the first one. Doesn't really matter now. And then depending what system you're using, we're going to hit download. And when you hit download, you'll get the latest version of it. It will start downloading, and then you want to open and run that. But you don't really want to use R. R itself is not the most nicest program in the world to use. And so what's happened since is there's been a GUI, sort of a GUI called RStudio being developed. So it's kind of like a graphical user interface for R. It makes it a little bit more friendly. It still has its own challenges, as it were, but when you get used to it, you find it's much more easier. So what you want to also do is download RStudio. So, and you go to the RStudio website and you really want to find the RStudio IDE for R. And you just follow it through. You want the desktop version and download RStudio desktop. Once you've done that, you install that, and together they'll work on your computer. These other options tend to be paid for. I generally work with the free tools. I'd say I recommend working with the free tools to begin with, and then switch to the paid tools after, once if you want to, whichever thing you want to do. That's fine. And there's also a third option with R. So you've also got RStudio Cloud. So you can create an account for free, and you're basically running R in the cloud. So this is really handy. It's really handy for actually doing live demos. I've got my own account set up. Once you set it up, you get like spaces. You can make new spaces. Here's one I made earlier. This is a Concode site. It's a Q&A for Q&As. And essentially you're running RStudio in the cloud. And this is RStudio. And this is the desktop version of RStudio. Okay, so it's not the most friendly thing you first see when you first open it, because generally you just see you're sort of like greeted with a coding page, and you're sort of like, where do I begin here? So what I do is a first sort of, if you want to follow this through, what I would do to begin with is just start an R Markdown document, and these are really good for like report writing. And so what you're doing is you're coding straight into a report. R Markdown just works like a Word document, and it's really the Word equivalent of R. So start here. So you start a document, start it as HTML. You can even code it in as a Word document, but we'll just do HTML for now. And this has the benefits that it's already coded in HTML, which means you can upload it to a website very easily. And this is where the importance of R and the power of it really does sort of shine through. There's different versions of it. You can code straight into presentations. You can even do what's called a shiny document, and a shiny document is interactive. So the interactivity is really important when you want to manipulate your data in real time. So if you want to you want to graph and things, hover above it, get the numbers, that kind of thing. And actually, it might be worth showing you straight away. No, I'll do it as a straight document for now. It's a lot easier. So just give it a name, start a document. There's our starting thing, and it gives you a template. So this space here is where generally you have your documents, so the things you're working on. And your documents can be either an R Markdown document, you can have a script file. I won't go into too much of these details, but this is where you do, generally where you open your documents and your data sets. This is where they all generally appear. This part here is where you do your coding. It's where I use mostly now to test where I'm coding. So if I'm writing something and I want to just see what that function does, you can paste it down here, and it gives you the answer. So cars. So what we're doing now is just running a summary on the cars data set. Cars is just a data set. If you hit cars, you'll see it. It shows you. It's basically just a 2-column spreadsheet with 1 column of speed, 1 column of distance. And how you code in R is you use functions. So summary is a function. If you pass in cars as an argument, it gives you a summary. So it's fairly straightforward. It gives you a summary in each of the columns. But we're not going to talk about that too much today. So this one, once you've created your HTML document, once you've created the R Markdown document, you can do things like knit it. So this button here lets you stitch it together, and it will ask you to save it somewhere. So I'm going to put it here. So let's call this demo 2021. And there you go, stitching it. So your output is now a document that contains a mixture of text, some information about the authors, the heading file, headings, text parts that you can edit. But the real secret is you can include code into your report. So you've now got code, and this is the output from the code. So you're completely working with raw data and with text and with code all together in one report. It's the equivalent of doing an Excel spreadsheet, copying it into a Word document, and keeping the connection and linking them. It works on the same sort of principle. And I think everyone's tried to do that, and I find that works, but generally something changes, and then all the links are broken, and everything's kind of, you know, it turns into a bit of a mess that you sort of have to curate a lot of the time. So as part of my presentation, I'm just going to show you how do you get data into how do you actually get data into R. So you've got your data set, you've got it as, for this example, I've got it as a text file. So I've saved my no, that's not one. I'll put it training. So yeah, here's my data file. So I've got a Hamwell data set. So let's just open that so you can see it. We're just going to open this in Excel. And no, it doesn't like it. Let's open this one. So this works. Yeah, so we've got a pretend data set. The kind of thing you kind of, if you work with temperature and humidity data, you're completely familiar with this. You've got your time, you've got your temperature, you've got your humidity, you've got your timestamps, you've got your data for temperature, you've got the data for humidity. Your data rolls on, and this is the file we were working with, I guess. This is one that opened, so we're not going to open it. We're going to import it. So this part of RStudio here lets you import data. So if you're importing it from an Excel file, allow it to do that. If you're importing it from flat text file, I'd recommend sort of using one of these two. There's a package called Reader, which makes it a little bit easier. We'll just use Reader to read it in. And so you're now going to go here and you're going to select the file you want to read. So we go to Browse. And this little tool here is like a helper to help you download files. And files can be anything. Today we're just going to work with temperature humidity data, but you can literally work with almost any file. I saved it in my input. This is the one that was working. It's now connected to it, and it's made some interpretation on the data. So it's read it in, it seems to be happy. It's correctly identified that the top rows were the names of the columns. So that's good. The formatting's gone a little bit funny, but under here you'll see there's a few options of how you can format these. But for now, we're just going to say it's read in time as a character. You can change it right here, and you can actually say this is actually a date, and it's actually a date time. So and it will make a guess at the formatting of it. So as we're doing this, it will assume. No, it won't let me check. I did format it. Let's see if it's still open. Yeah, so it's made a guess that the first part was the month. So this is how it's going to be passed into R. So we're now passing the data file. We're now telling what these columns mean. So this is actually the date, the day. This is the month. This is the year. This is the hour, minute, second. So we now have to specify that. You have to tell R explicitly what each part is. So actually the first bit was a day, second bit was a month, third column was the year, and then hours, minutes, and seconds. I think it won't make a difference because there's only seconds will come up as zeros, but let's see if that works. No, okay, let's just change that to day and that to month, maybe that'll. Yeah, like that. Okay, so that's good. That's correct. So that seems to be correctly formatting the date. In R, it does it on ISO. So it's I can't remember which ISO it is, but it's year, month, day, hour, minute, second. So that should be correctly read in now. You can also tell what these are. So you've got choices, so you can have them as these are your options. And these are the different types of data types that R can likes working with or can handle. At the moment it's guessing it's a double, which seems pretty good to me. So a double is a integer, is a number with a certain number of decimal places. You can be, I think you can be specific. It will just probably assume it's a, it will see, you can specify as a numeric, or you can specify as an integer. An integer is a number with no decimal places. So I think this all seems to be happy. My format, I don't know why this formatting's gone a bit weird, but here it actually, whilst you're doing this, it's saving the code. Let's just import it because the formatting's gone a bit weird. Okay, and it actually gives you the code. So if you were to just copy that and run it again, let's delete the pluses. It just performed the same thing again, but you've just done it with code. And now that you've got the code, you can just save that, you can copy that. And put it into your file. So we're not going to work with the cars data. In fact, we're just going to delete all of this. So let's just delete this, and I'll show you how you put code in. So the R Markdown document gives you a pre-formatted text, but what we want to do is create our own. So we want to add, and how you add little script files into your document is by clicking here. You can say I want a little R script, and this will, you can just plonk your code in. That code return this. This is now your data frame, and when it's downloaded successfully, it appears here. And these are now your data sets. These are data sets you'll be working with. And so here's your data file. Here's the code for it, and it's now embedded into the document. So let's just have a look. So the code for viewing some of the data might work. You can just see the top. That shows you the first few lines of it. So you say how many lines of first column, first rows of your data you want to see. So you just want to see 5 rows. If you knit that now, of course you get an error. Function. So this is good. This is a good thing. So this is a good error. This error is saying cannot find the function read CSV, and this is an important thing. So R works by having a predefined set of libraries which you need to call to upload a bunch of functions. So the functions are contained within packages within R, and R has a huge repository of them. So R has, I think, about 14,000 packages at the moment, and it's ever growing. What the packages do is modify the base functions within R. So R just gives you a set of base functions, and what people have done is taken those base functions and turned them into packages, and the packages do things like give you graphics, produce nice charts. I'm not going to go into it too much, but they produce models, so they allow you to do things and work with data in different ways. So we're just going to upload 2 packages that are available, and these are the main, these are the important ones that you sort of use a lot, that I use a lot anyway. And it's worth getting familiar with these, because you can do a lot of things with the data once you've downloaded it, and these help you a lot. And this is how you install it. I think because I've installed it already, it shouldn't, it's throwing up an error, but I've installed them already, so I'm just going to load them up. So how you load them is use library, Unfortunately, you can't do one. You can't do them together. You have to do each one separately. And so we just loaded up the packages. And now, if I hit net, it will download the packages and upload the data all at the same time. So there you go. So this is now embedded into a document. So every time you hit knit, every time you load this document, it's downloading the data and showing you an output of it. So the advantages of doing this is, just imagine that if you want to change your data file, you can do that very easily. Just change the name here. If you're adding data to your data file, it will continually update by itself. You don't have to, it's not like an Excel spreadsheet where you have to tell it the number of columns you're going down to. So this is just happening automatically. And you can also like run it as chunks in here. So you can get the same output within your R session just here. Okay, and once you have your data, you might want this to run silently in the background. So you don't, when you knit it, you don't want people to see this appearing in their report. So you can actually turn it off and on. So you can actually say, you can specify what people see. So if you just want people to see just the output, which I think I want to show here, you can do that. So let's just do that again. We're just going to knit it. So they shouldn't see the code. They should hide the code, and all they see is the output.
Sorry, but I just that last section where you made that change. How did you do that?
All right. So here you have a little cog.
Okay.
And then you can specify different levels of what you're going to show. So you can have code here that you either show or don't show to people as they're uploading, as they're knitting their report. So if you have a report and you just want, you just want the outputs from the report, you just show output only. If you have this code and you want to show both, you can say both. But you can also like show nothing and just run the code. Okay. So it's like it's running in the background.
I didn't know this. That's very helpful. Thank you.
Yeah, so that's really nice, because I mean, if you're uploading these packages and you don't want, you just want them to run silently. You don't really want, it's not really important for this report. You can do that, but you can also like don't run code. So if you've been working on something here and it's you don't want it to run, you just turn it off. And that's really nice. For now, we just want to see the outputs, because we actually want people to see that there's a data. The other thing you can like, and this is the nice thing, you can start mixing text like you would see in a Word report with the outputs of code, or with code. So this is how you edit text. So it's written in Markdown, which is like a typesetting language. It looks intimidating. It's not the most friendly thing in the world, and there are ways. It is getting friendlier to how you would code it. So you can code it. If you have the latest version of RStudio, I think it lets you code it as if you see it. So if you hit this little button here, this starts letting you code as if you're going to see as in the outputs, as it will appear in the output. So, and you sort of have how you would almost like text edit in a normal text editor document. So, for argument's sake, let's say this is my heading of this report. I want it to be heading 1. I want it to be really big, and it works like HTML. So, let's say climate report, and I want some text. This is my climate report for world data. Whatever you want to put in there. If you knit that now, the headings change and the report suddenly starts showing the text you've been typing. So you're now mixing it all together. I don't know if I explained that very well. But I think you can kind of see that the power of that is really important as you like. I'm just going to switch back to normal editor. You can see like where you're typing it in text. Here is the data. And if you knit that, it will change again. So you can type it in using directly into the text editor or into the Markdown editor. You can see the new text appears here. Here is the data. And we're just going to carry on. So we'll carry on, and you can do it straight here. So if you do 2 hashes, you get you specify the level of heading. There's a lot of information about how you edit our Markdown documents. I'm going to not talk about it here because it's far too much information. But we'll leave it there. But like so. We'll just carry on working with the data. So what we're going to do first is like graph the data. So we now have the data. We've downloaded it. We've got it into our report. We now want to graph it. So here is my graph. So type it straight into report. So we're now going to add a little bit of script. So again, we can add an R script into our report. And it will appear where you specify. And we've pulled our data Hamwell, and I'm not going to try and do this too live because here's some code I created earlier. This gets a bit, hopefully this is not going to be, hopefully this will work. And as I said, we've created, I'll delete that for now. As I said, we've already downloaded the data, we've called it Hamwell, and we're now going to use a plotting function called ggplot. And this is how, like, say, ggplot works exactly the same way as you would downloading data. So you have your function, which is ggplot. First argument it will take, and if you click on it, it will show you the arguments it needs. So it needs a data argument. And the data is the Hamwell data set, and then it needs some mapping. The mapping is defined by AES, which stands for aesthetic. You don't need to know this, but like it basically says what do you want on your x-axis, what do you want on your y-axis, what color, do you want the color of the charts to change depending on the time of day or the temperature or things like that. So that AES becomes really nice, but it's a little bit complicated if it's the first time you've seen it, it's a little bit complicated to get your head around when you put things in AES and when you don't, and why you do and why you don't. But anyway, so you have your plot, you're going to be plotting Hamwell data, and you just chain what you want to appear on the plot together with pluses. So you just literally add them onto your base plot. So if you plot this without any without specifying what you want to see on your plot, you'll get a blank plot, but you won't get anything on it. So you need to actually start adding stuff to it. So here you go. Here you have your ggplot, it's Hamwell data. And now you can start going into what types of chart ggplot have, and you can get an idea. If you go to the ggplot platforms, you'll see there's like hundreds of types of chart. And it's really like it really sort of does become left to your own imagination what you want to do with them. But there are standard ones. So here's a good thing to start getting used to using is the cheat sheets. And it doesn't, and it's not there, of course. Anyway, so we can just carry on. We'll carry on point. So you can have points. GM points. There's a whole bunch. There's a whole different type range of them. For now, we're just going to do a line plot. This is kind of the standard thing you would do with temperature and humidity data. So we're going to do a line plot. We're going to plot in. We're going to specify what our x-axis is. X equals time. Y equals. So I need to change that to this. So this is why I want to see the data. So you can say I want the first y-axis to be the temperature. That should work. Yeah, so you can like copy and paste that in. You do need to put some of these things into quotation marks. They need to be, I think you need to be consistent with your quotation marks. And there are different types of quotation marks. If you're editing this in Word and you copy it into R, I will save you a lot of time by saying the quotation marks in Word are not recognized by R. I found out it took me a very long time to figure out why some code wasn't working, and it was just the quotation marks. And you can also specify the color. Like, so for example, for this one, we're going to go deep pink. We can hit play on this, and this will run this little code chunk, and it should give you a chart. And if it doesn't, we can, it might be good. Yeah. So there's our chart. So the outputs appear here. Here's your chart. And it's a nice, straightforward temperature plot. It's good enough. You've told it on the the x-axis what time, and it's correctly formatted the date. On the y-axis, you've got room 1 temperature. It's truncated it. It's done things like that. So it's given you a straightforward temperature plot, which is what you're going to do all day using Excel. If you do this sort of thing, this is the kind of thing you do quite a lot. The nice thing is, if the data changes, this code, you don't need to change this code. If you're adding data to the bottom, if data is always being expanded, you're always adding new values on here. It doesn't matter. The same code will run exactly the same way. If as long as the names are kept consistent and the column names are kept consistent. So, and I'm just going to knit that into our document. So here's our report. Here it contains, here's our climate report, here's the data, and here's the chart. We can even do a little summary of the data, just include that in our report. And we don't want to see the code because we just want people to see the thing. And also with the chart, you can also add to it. So you don't have to just stop with one chart, or one line. You can just add the humidity data. So we want to add humidity as well. Let's give that a different color, blue. And actually what you can do is actually specify, you can put color into the aesthetic. So actually we can actually do that here. So we can put color as the actual values, so the color will change depending on the value. It should work. Actually, let's knit that straight there. Let's see what that produces. There we go. So here's our climate report. Here is the data. Here is my graph. Here's a summary. So you can now see the temperature is changing with the humidity, and it's giving you a scale on the side. So that's quite nice. And that's quite a nice thing to do if you're trying to highlight areas where things are approaching certain conditions. You can actually specify these to give you different colors at different ranges. So if you're going above a certain limit, the color will change. You can make it bright, just make it stand out. You can do lots of things once you've got your basic chart ready. So you don't have to stop with just having a basic chart. You can make it fancy. You can change, for example, the labels. So on the x-axis, I think it's pretty obvious it's time, so I don't want anything there. So I'm just going to get rid of the x-axis label. On the y, I want to say just temperature and humidity. You can give it a title. Chart. I want to say here's my summary and my graph. You can just keep adding to it. And also what you've got is built-in themes available. So I don't want to see this grey background. There are themes available. These are the different themes that you can specify. I just want a plain, just black and white background. And now when I'm at the report, we're now getting towards like my finished product. And this is, and there's my standard temperature of this chart. There's a summary under data. There's this part here, which is giving me warnings. I don't want people to see the warnings. You can also turn them off. And I don't want to see people see the messages. The messages and the warnings is telling you in the code there's something going on. The case that it is the warning, so it's not a critical error, but it's something that's occurring, that there's missing values in the data set. You can see in here in summary that there are missing data points. For this particular data set, I know it doesn't matter because I think it's down the end here. And we'll just carry on. And we can hit that again. And so now the errors have been removed. We still have the summary. We still have my graph. And that's my report. So in, something like this, which in Excel, I'd say would take, even if you're really quick with Excel, probably half an hour to an hour to do, maybe, and getting all the formatting right and the charts and all that kind of thing. This is like, this is like sort of a morning's work, like, before your first cup of tea in the morning, and you can go away and have a nice fancy report ready for your boss, and there you go, your day is over sort of thing in the morning. Do you have any questions? I think this is a good point. I think I've been talking too much. Is there anything else you want to see? Or
Bob, I have some questions.
Yeah, please.
So I do the same type of analysis often.
Yeah.
And I kind of, so what I do is I put all my sensors in one file. So I analyze like 30 sensors at once by constantly running the same code. But I'm really struggling with loops. Like I know I should put loops in, but for some reason they never work. So the only thing I do is just I program the same thing for column C, B, and C, and then for D, and so on and so on. So I just make it do the same analysis all over again, while I should probably work in a loop. I'm conscious of that fact that I use too many lines of code. Do you have an example somewhere of where you analyze multiple data sets and you work with a loop?
Okay, I'm gonna confess, I've never used a loop ever in R.
They never work. It's
I've never used
my
one.
lack of talent, but
No, I've just never used one. You don't have to, is basically my answer. You don't have to use loops, and the reason is you've got other functions that are take a bit more time to understand and get your head around. But once you've figured out how they work, you don't have to do looping in R. So there's things, what are they called? There's a library. So we've uploaded this package called tidyverse, and inside that there's another package called pear. These things are all named after cats. A lot of these packaged things are named after cats. So as part of the tidyverse, there's a package called pear. There's 4 cats per. Pear is a really good one because it allows you to loop without having to create a loop. And so it's basically a wrapper for a bunch of loops that you can perform. And there's various ways you can do it. And you can either go, for example, you can loop across the rows, or you can loop across the columns, or whichever way you want to go, whichever way you want to do it. And the reason why you don't need to necessarily loop is because you reformat your data. So I didn't really talk about this. So you can see here, what I'm doing is, for the y-axis, I'm typing in the name every time. And this is really not, I would say, not good practice. What's better practice is to actually tidy it. So this is like a whole nother talk. This is like another hour added on, but very simply, for the Hamwell data, I think you can do something called pivot longer. And if you put in Hamwell as your first data set, so this is a pipe. You can pipe data into your next thing. So pipe data into Hamwell. This is a good question. So if you ever get stuck, this is how you use the help files. You look at pivot longer, and you look at what the functions are. So the first thing it needs is data. Second thing it seems to need is columns. So you need to tell it which columns to pivot on. But I want it to pivot on all the columns. I think I do minus time. So it's got time, temperature, room 1. You can imagine your data set has multiple rooms. So you've got 100 rooms. You don't want to be pivoting on each one specified. So if you do minus time, it will pivot on everything else minus time. And I think that should do it. And then if you do something like names 2, I think this might work. I'm not sure. Actually, let's just see what that does. You see, it's hard to explain, but you see it when you see it in the finished product. Yeah. So okay. So you see it in the finished product. So what I've done is pivoted it longer. So you've done like a pivot table. And you've pivoted time so that every single one of these columns now, so it's turned, it's quite hard to explain this, but you've turned 2,800 columns into 5,000. So you've taken this column and put it underneath this one. And this is like, and separated them by room and temperature and humidity. So this is really important because now you've kind of tidied it a little bit. I wouldn't say it's been tidied completely, but you've tidied it a little bit. So now when you're doing your graph, you don't have to use for loops or anything. You don't have to say go across each column or any of this kind of thing. You've pivoted it, so you can just say, instead of x equals these things, you just say x equals value what is it, value and name. It's just giving these names to it. So you could do something like color name. If you run that, so, and I haven't told it I want a line chart, and I haven't put anything into aesthetics, so I have to put these into aesthetics. Right. You must select one column. Why have I not selected? Anyway, oh, oops, I'm done it.
Bob, it's so for me, it's okay. You don't have to go
Sorry,
to
if
I know I have to get into pear, then I will just make sure that I get it. Oh,
there you go. So you get your graph, but now it doesn't matter how many columns you've got. You don't have to use a loop anymore. So and this code is now like completely universal code. So it doesn't matter what, as long as you keep your data like So it appears with time, name, and value. You can have as many columns, many data as you want. It doesn't, and ours doesn't have limits like Excel and things like that. So, so that's a good. It's a
Okay,
good.
thanks.
It's called tidying. Yeah. Anyway.
And I will definitely let somebody else also ask questions, but if there's no one, then I will ask a second question.
Yeah.
I might throw one out there real quick. Oh,
Go for
sorry.
it.
Savannah, did you have something? You're good.
I also had a question, but you can go first. You're good.
I just wanted to chat about the temperature and relative humidity, having it within the same chart, because I've noticed that's kind of a standard kind of across the industry. But then I think coming from a pure data side, it's like I'm always hesitant to put multiple scales in one chart. So I guess, do you have any thoughts on like pros and cons? Because like temperatures, you could see the fluctuations maybe a bit better when it was on its own sort of scale.
Yeah. Oh, I don't know. That's a Nigel. Yeah, I see Nigel.
Yeah, Bav, that's an interesting point, and Emily as well. I think in the National Trust we plot graphs on 0 to 100 for both temperature and RH. And psychologically, the scale of variation that produces that you see with your eye accords with the level of alarm or interest that we take in that data. So there's a kind of psychological element about how we choose those scales. And so we find 0 to 100 for both axes works well for us. And it's actually really useful to see both those traces together because they are reciprocal in certain ways, and they're telling you different things, or telling you sometimes confirming information when you look at them together. So we find those particular axes work really well for us, but I know other institutions would use different values. I found 0 to 50 for temperature and 0 to 100 for RH often produces overlapping lines, which again makes them a little bit more difficult to visualize and interpret.
Cool, that makes a lot of sense. Thank you.
Thank you, Nigel. I don't think I've ever known why. So that's good work.
I actually really, Emily, I just usually sort it when I do it with R. I really sort it to minimal temperature -2, maximum humidity +2, right? So then you just have same scales on both ends, but you just see the maximum difference in your scale.
Yeah, it's a really good way to control the data because they're completely linked. So it does make sense. And that on the left side, you put, for example, temperature, right side, you put relative humidity, and then you have a good scale. So yeah, it shouldn't be a problem. It would be weird to separate them as they're completely linked to each other. So yeah.
Savannah, you had a question.
I just wanted to ask, we have like an R Markdown document, and when we knit it, it knits into an HTML. So how does that work for sharing it with other people? Like someone you might not be sure if they have R, like how does sharing code work with our Markdown document?
Excellent. Good question. So as I was saying, right, one thing I wanted to show, but I think I forgot. Is this doesn't have to be a file on your computer. So you can literally just grab it from the web. So here's one I created earlier. So here's my GitHub site. And I've got data files in here. So I've got a test set. And I have somehow more data. And I think I showed this in the, I think I sent this around in the email. But you can pull it off straight from GitHub. So what you can do, this is you stored it in GitHub or on the web or wherever it is. As long as it's on the website, on the internet or from an SQL server, whichever thing your company uses, your organization uses, it will be available on the web. So if you look at the raw data, so you have to actually work with the raw data. And this is now just a URL. So you can actually just literally, this should work. Probably, fingers crossed this will work. It's now just talking to the internet and putting it straight off the web. So that's one way of sharing data. And how do you share your Markdown document? document. So you can just, once this entire thing now is in the web. So there's no, all you need to do is literally just share this document. So you can email this. This is your notebook. You can just email it to somebody. All the things will, the person will have to set it up, like have these packages installed and the same sort of thing. Or you can even share it through GitHub again. So you can upload your code and everything into your GitHub site. So this is your thing, you can literally upload it into here. You can use a cloud, you can use a cloud version of it, so you can upload it. You could just copy and paste your code into here. I think you can just dump your R Markdown document into your RStudio cloud, and it should still work. All of the data, basically everything, all of the data, all of the things are web. So there's nothing apart from sharing a what is it, like a tiny 2 kilobyte file. That's all you're sharing, and you've created this same report. Does that make sense?
Yes, thank you.
So if I was to email that to you and you had all these libraries installed, and you'd be producing the same report.
Yeah, I have another question, Bob, but more about, and I know that we have had this discussion before, so I don't know if you've gotten any further on the topic. I'm very interested in kind of storing types of calculations into a certain function. I'm also not sure if I'm using the right word. So, but basically what I want to do, for example, with the new ASHRAE standards, I want to have A, A1, A2, B, C, and I want to kind of compare my data to these standards and see, and make sure that I don't know how to explain it, but I want to run my data through one of these calculations to kind of see, okay, so much time as I fall out of this category at this percentage of time, or I fall mostly out of this category in summer or winter. I know how to do the calculations. The only thing that I don't know is kind of how to store these calculations into a function.
All right, good. Yeah, good question. So functions, yeah, so R is a functional language, and you can store everything into it. You can pack it all into a function. So anything you do, So for example, this, if you want this as a function, so you want this chart to reproduce on any date on your data. It's really, you just literally plug it into a function. You can just say, I can't remember what we say, func graph my data. Say you want graph my data to be a function, and you specify it by this array. So you say this thing is going to be this. You can use equals as well, but you can say, so you want it to be a function. You want it to take one argument, which is just data.
Yeah, I think the problem with these functions for me is that they consist out of multiple arguments. It's this and or that, if this or that, you know, it's a bit.
Yeah.
And
yeah.
I get, it gets messed up at that point where
you can, again, like if you like, so we've specified a line graph, you could easily change that to like a point. So you can have like, there's an infinite amount of charts you can, well, there's loads of charts you can have. But so let's say these are all the options you have. You've got area chart, bar charts, blank, contour, etc., etc., etc. If you want a point instead of a line, there's a thing you can do called switch. You can switch, so you can have two arguments in here, and you can have graph. Sorry. I can't remember the syntax for it, but I'd have to look at this. But you can do something like switch, where you say Again, you don't have to use, yeah, here you go. So once you type switch, it gives you an option. So if graph type is, if you say in graph type you want point, so you could have line, well, I can't remember how you do this now. But if you say like, you can switch the objects around. So if you want to action equals geo, if you say line, here, if this becomes, oh, this is going to be, it's going to be a bit more technical, sorry, but like, if you wanted a line chart and you put, and the person put something like this, I don't think this is correct, but you can switch out arguments. So you can, if someone says line here, it's part of their function. So this is maybe it's best not to go into this too much, but you can switch out which changes you want to occur. This is what I'm saying. Like, you don't have to use like for looping and if statements, and you can avoid all that. You can avoid a lot of that complexity. But I do use if statements quite a lot. Definitely, I think that's kind of like a standard code thing. But again, again, that's like a lot. It's a lot more talk. It's like quite a long lecture.
Yeah, I think it's just something that is quite complicated. I really have asked quite a lot of people, and I've never really gotten an answer. So I've never really been able to do it. Because I'm going to post it in the chat. These are all the conditions that something needs to answer to be like a climate B.
Yeah.
Sorry, it's like usually it's a bit more visible when it's really code, but it's if and I still don't know how to do it. If anybody in this group knows how to do it, please tell me. It would be of great help.
Kind of an idea to break that sort of qualification up into a separate function, if you get what I mean. Like, do one where it's like the function determines which, sorry, what did you call them again? The standards? Or
it's the ASHRAE B standards, but I already calculate a lot in advance. Like, I already calculate my seasonal averages, my ranges. I calculate all these things in advance, and basically it needs to come together into this. I want to then say, with all these things that are calculated, does my data set respond to a climate B with all the conditions stored in B? If that makes any sense.
Yeah, I think so.
I also don't know. I thought with code everything was possible, but I'm stuck.
I think everything is possible. It's just at what point it becomes possible in the process. Interesting.
But thanks a lot, Bob.
No, yeah, I think
I've got a question, a simpler question, because I'm starting at a lower level on this, on R at least, but where you've run that pivot longer command, and you've started with the Hanwell file, are you transforming that file permanently, or are you just creating a temporary version of it which is transformed as a data frame?
No, it's a temporary version. It's it's a temporary version. To transform the data, you'd have to do something like, you have to tell it, so Hanwell, I've changed it. Does that make sense? So
yeah, so you
have to explicitly say, otherwise it will just remain the same.
Yeah, and as a general rule, would you normally not use permanently transformed files? Would you always just make temporary transitions in your code and start with the base data, or would you actually want sometimes to totally transform a file?
Sometimes, yeah. Sometimes you don't, like, transforming is pretty memory heavy, and I mean, these are relatively small data frames, but if I've got like some of the ones at work are like, let's say about 300 sensors. If you're transforming that every time you're uploading it, it can really slow down the whole thing. So sometimes you do want to transform it and then work with that saved somewhere else, and maybe try and add to that. But
Yeah.
it gets more and more complicated. So you can transform like a whole year's data set, and you just sort of store that somewhere else, because that's going to be like there's a really big data frame. When you transform it, like you're normally doubling the length of it. So you're expanding, you're making these huge data files.
Yeah, and it's interesting because in the package we use at the moment called Systat, which is a very old package with the scripting language, we run building management system files which can take 40 minutes to run a script where we are changing the data file. So it's interesting, yeah, that it may be quicker to do this with the temporary file approach you're suggesting. Thank you.
Yeah.
Yeah, and I have to say that if you don't transfer them, like I always create, I think, a lot of numerical information and at least like 15 plots for every data set.
Yeah.
I have at least like, let's say 30 to 100 data sets. It takes 1 minute. Allez, not even, it takes a few seconds and it's all done. So it's really, really great.
That's fantastic. Yes, if we can get that sort of speed. Thank you.
Yes, for example, that one, the 134,000 row object turned into nearly 1 million, but it's a little bit tidier. So that's the original. Anyway. Any other questions?
I think just a general tip as a kind of beginner as well. I really think what is really important is your import, and to make sure you use a lot of standard import formats. And if you use like standard datetime and you use like, it's a bit kind of annoying with the point and the comma in Excel for people that are not American.
There's no standard.
Commas. But just use as much as you can standard formatting. And if you don't, really adjust, as Bob showed, your import sheet to make sure that your program can read it, or you'll constantly run into problems.
And no one uses standard date times.
I do.
You know, yeah, like, I mean, London data logger manufacturers use standard date time.
I know, it's true.
Yeah.
And when you're importing data, how would you deal with missing data elements? Because most data sets will they'll have an NA or a dash or even a point, something in place of a real point or real number.
That's a great question. Yeah. So some of the functions don't work with NA data, and you have to say you then have to decide what you're going to do with it. So you can either remove it, it depends, you know, I think it depends. Like if you're doing statistics and you remove data like missing values, you might have to account for it. If you're comparing January this year with January last year and 50% of your data is missing this year, can you do that still? You know, you've got to for me, generally I just tend to remove it, just ignore it. So but yeah, I'm sure you understand. These things come with huge caveats, you know.
Yeah.
But Nigel, it ignores it by default. So if you have, let's say, 1 week of missing data in a year, it will just like not calculate those NAs.
Yes.
Which is, for most functions, it will still work. So it will just do like pretend like this week has never existed. But you can also say, for example, if I have a lot of missing data and I don't want it to influence my numbers, my numerical calculations, I often take the median. I say if NA, then input median, but also for only the calculations where I know this is okay, because I also see it in my graphs, right? I also see in my graphs that I have like a total flat line, so I know it was an A. It was not there. It's never a total flat line.
Yeah, we don't have many of those in our graphs either. So yeah, thank you.
All right.
Any others? Yeah, that's it. I think that's an hour.
I think it was a great presentation, Bob. It was very clear. Huh? You always doubt yourself, but there's no reason to.
Yeah, I'm gonna stop the sharing and stop the recording. And Elise, can you? Oh yeah, stop recording. Thank you, everybody.
Yeah. I'm just going to say that Sebastian has said that we all kind of do these analyses besides each other. It would be great to share code. I actually think that on the Concode website we have, but I should check how I should do this. And maybe Avery will know more than me, but actually I think we have a possibility to share code, but some of the people here have GitHub pages where they have their code. So I think there's so many people with temperature, relative humidity code that it could indeed be interesting because it's something that we all need to analyze all the time.
That would be great. I'll take a look on the site.
Oh yeah. Yeah,
but yeah, it's not on the site yet. I think it's possible, but Buff definitely has a GitHub page. Buff, you have GitHub.
I've tried to connect it to our. You can connect it to your RStudio. There's ways of connecting RStudio to like GitHub and loads of different like really good things. So when you're doing code, you can upload it straight there. I haven't got it to work yet, but Nathan gave a talk. Nathan from Conserve gave a talk. When was it? Quite early on. Is it early?
It was one of the first webinars that we had, yeah, and
that
one is on the site, that video.
And that's on the site, so please do check that out. That's like setting up your GitHub. You don't have you can get it connected to one, and it becomes like really easy. But then you can actually just upload code there as well. But yeah, GitHub's the place to do all that kind of thing, I think. So
I've actually been using your Shiny website there for some climate data. It was just an easy way to show some of that data.
Ah, good. It's on you. Okay, I'm going to stop the recording here.